Imagine floating in the vast silence of space, only to hear a faint, eerie hum that seems to come from nowhere and everywhere at once. What could it be? A distant star collapsing, a black hole devouring a galaxy, or something far more mysterious? Space, as breathtaking as it is, holds secrets that are as terrifying as they are fascinating. Today, we're diving into the unknown to uncover the 25 most terrifying things in space you never knew. From cosmic anomalies that defy explanation to forces so powerful they could wipe out entire worlds, the universe is not just a place of beauty, it's a realm of spine-chilling mysteries. So buckle up, because by the end of this journey, you'll see the stars in a whole new light, and maybe even feel a shiver run down your spine. Stay with us, because what lies ahead will change the way you think about the cosmos forever. Now turning to the first terrifying phenomenon on our list, we encounter the Great Attractor, a gravitational anomaly so powerful that it's pulling entire galaxies toward it. Located approximately 250 million light-years away in the direction of the constellations Centaurus and Hydra, this mysterious force is hidden behind the dense plane of the Milky Way, making it incredibly difficult to study. The Great Attractor's immense gravitational pull is drawing not just our galaxy but thousands of others toward it, creating a cosmic tug of war that defies our understanding. What makes this even more unsettling is that we still don't know what it is. Is it a massive cluster of galaxies, a supercluster, or something entirely unknown? The fact that such a colossal force exists yet remains shrouded in mystery is a chilling reminder of how much we still have to learn about the universe. And as we move forward, this sense of the unknown will only deepen. Now turning to the next spine-chilling phenomenon on our list, we delve into the terrifying reality of rogue black holes. Unlike the black holes we often imagine anchored at the centers of galaxies, rogue black holes are cosmic nomads wandering through the vast emptiness of space without a fixed home. These solitary predators are born from the collapse of massive stars or the chaotic mergers of smaller black holes, and once set loose, they roam the universe, devouring anything unfortunate enough to cross their path. What makes rogue black holes so unsettling is their unpredictability. Unlike their stationary counterparts, these wandering giants can appear anywhere at any time with no warning. Imagine a black hole, invisible and silent, drifting through the darkness, only to suddenly pull a star, a planet, or even an entire solar system into its crushing grip. The sheer force of their gravity is so immense that not even light can escape, making them nearly impossible to detect until it's too late. The potential threat they pose is staggering. If a rogue black hole were to pass through our solar system, it could disrupt the delicate balance of planetary orbits, flinging planets into chaos or even consuming them entirely. The thought of such an invisible, unstoppable force lurking in the cosmos is enough to send shivers down anyone's spine. And while the chances of a rogue black hole encountering Earth are astronomically low, their existence reminds us just how unpredictable and dangerous the universe can be. As we continue our journey through the most terrifying phenomena in space, the next stop will take us to an even more explosive and destructive force: gamma-ray bursts, the universe's most powerful explosions. Now turning to the next cosmic horror on our list, we encounter gamma-ray bursts, the most energetic explosions the universe has ever known. These bursts are so powerful that in just a few seconds, they can release more energy than our Sun will emit over its entire 10 billion-year lifetime. Born from the collapse of massive stars or the collision of neutron stars, gamma-ray bursts are like the universe's ultimate fireworks, except they're anything but celebratory. What makes gamma-ray bursts truly terrifying is their sheer destructive potential. If one were to occur within a few thousand light-years of Earth, the intense radiation could strip away our planet's ozone layer, exposing all life to deadly ultraviolet rays from the Sun. Entire ecosystems could collapse and the surface of the Earth would become uninhabitable. In a matter of seconds, a gamma-ray burst could sterilize an entire galaxy, leaving behind nothing but a lifeless void. The scariest part, we wouldn't see it coming. Gamma-ray bursts travel at the speed of light, meaning there's no warning before they strike. By the time we detect one, it would already be too late. Fortunately, the likelihood of a gamma-ray burst hitting Earth is extremely low, but their existence serves as a stark reminder of how fragile life is in the grand scheme of the cosmos. As we move forward, our journey through the universe's most terrifying phenomena takes us to another eerie mystery, the Boötes Void, a vast, empty region of space that defies explanation. Now turning to the next chilling mystery in our cosmic journey, we arrive at the Boötes Void, a vast and eerily empty region of space that has puzzled astronomers for decades. Known as one of the largest voids ever discovered, this enormous expanse stretches over 300 million light-years across, yet it contains almost no galaxies. To put that into perspective, if our Milky Way were placed in the Boötes Void, our nearest galactic neighbor would be millions of light-years away. The emptiness of the Boötes Void is unsettling. In a universe teeming with galaxies, stars, and planets, this region stands out as a cosmic desert, a place where the usual rules of space seem to break down. Scientists have theorized that such voids could be the result of the universe's large-scale structure, where matter clumps together in some areas and leaves behind vast, empty spaces in others. But the Boötes Void is so unusually large and empty that it challenges even these explanations. What could exist in such a desolate place? Some speculate that the void might be home to dark matter or other invisible phenomena that we have yet to detect. Others suggest that it could be a remnant of the early universe, a relic from a time when the cosmos was still taking shape. And then there are the more imaginative theories. Could the Boötes Void be a gateway to another dimension, or perhaps the result of some ancient, catastrophic event that wiped out all matter in the region? The Boötes Void serves as a haunting reminder of how much we still don't understand about the universe. Its emptiness is both a mystery and a source of cosmic dread, a place where the familiar rules of space and time seem to dissolve into nothingness. As we continue our exploration of the universe's most terrifying phenomena, the Boötes Void stands as a stark symbol of the unknown, a void that challenges our understanding of existence itself. Moving forward, our journey takes us to another enigmatic force shaping the cosmos: dark matter and dark energy, the invisible rulers of the universe. Now turning to the next enigma in our cosmic exploration, we delve into the shadowy realms of dark matter and dark energy, the invisible forces that dominate the universe. Together, these mysterious entities make up about 95% of the cosmos, yet they remain almost entirely hidden from our understanding. Dark matter, which accounts for roughly 27% of the universe, is an invisible substance that does not emit, absorb, or reflect light. Its presence is only inferred through its gravitational effects on visible matter, like galaxies and galaxy clusters. Without dark matter, galaxies would fly apart, unable to hold themselves together under the force of gravity alone. Yet, despite its crucial role, we still don't know what dark matter actually is. Is it made of undiscovered particles, or is it something even stranger, defying the laws of physics as we know them? Then there's dark energy, an even more perplexing force that makes up about 68% of the universe. Unlike dark matter, which pulls things together, dark energy is thought to be responsible for the accelerated expansion of the universe. Imagine the universe as a balloon, and dark energy as the force that keeps inflating it faster and faster, pushing galaxies apart at an ever-increasing rate. But what is dark energy? Is it a property of space itself, or is it some kind of energy field that permeates the cosmos? The truth is, we have no definitive answers, and that uncertainty is what makes dark energy so unsettling. The unknown nature of dark matter and dark energy fuels some of our deepest cosmic fears. These forces are everywhere, shaping the universe on the grandest scales, yet they remain invisible and untouchable. They remind us that, despite all our advancements in science and technology, the universe is still full of mysteries that defy explanation. What if dark energy continues to accelerate the expansion of the universe indefinitely, leading to a cold, dark, and empty cosmos? Or what if dark matter holds secrets about the fundamental nature of reality that we are not yet ready to comprehend? As we ponder these questions, we are reminded of how much of the universe remains hidden from our view. Dark matter and dark energy are not just scientific puzzles, they are cosmic enigmas that challenge our understanding of existence itself. And as we continue our journey through the most terrifying phenomena in space, these invisible forces stand as a haunting reminder of the vast, uncharted territories that lie beyond our reach. Moving forward, our exploration takes us to another profound mystery, the Fermi Paradox, a question that has puzzled scientists and thinkers for decades. Now turning to the next enigma in our cosmic exploration, we confront the Fermi Paradox, a question that has haunted scientists and thinkers for decades. If the universe is so vast, with billions of galaxies and trillions of stars, why haven't we found any signs of extraterrestrial life? This paradox, named after physicist Enrico Fermi, challenges our assumptions about the existence of intelligent civilizations beyond Earth. With so many opportunities for life to arise, the silence of the cosmos is both puzzling and unsettling. One of the most compelling explanations for this silence is the concept of the Great Filter. This theory suggests that there is some kind of barrier, a filter, that prevents civilizations from reaching a stage where they can communicate across the stars. The terrifying part, we don't know where this filter lies. Is it behind us, meaning that the emergence of intelligent life is so rare that we've already beaten the odds? Or is it ahead of us, waiting to wipe out civilizations before they can spread beyond their home planets? If the Great Filter is still in our future, it could mean that humanity's survival is far from guaranteed. Another possibility is that advanced civilizations self-destruct before they can make contact. Whether through war, environmental collapse, or technological disasters, the idea that intelligent life might be its own worst enemy is a chilling thought. Or perhaps extraterrestrial civilizations are out there, but they are so advanced that they have no interest in communicating with us, viewing humanity as too primitive to engage with. The Fermi Paradox forces us to confront the possibility that we might be alone in the universe, or that we are surrounded by civilizations that are either too far away, too different, or too dangerous to interact with. It's a question that not only challenges our understanding of the cosmos, but also our place within it. Are we a rare spark of intelligence in a vast, empty universe? Or are we simply too early or too late to witness the rise of other civilizations? As we ponder these questions, the Fermi Paradox serves as a humbling reminder of how much we still have to learn about the universe. It's a mystery that invites us to look beyond our own world and consider the possibilities and the dangers that lie in the stars. And as we continue our journey through the most terrifying phenomena in space, the Fermi Paradox stands as a haunting reminder of the unknowns that still await us. Moving forward, our exploration takes us to another cosmic mystery, zombie stars, the bizarre remnants of supernova explosions that defy our understanding of stellar life cycles. Now turning to another cosmic enigma, we encounter zombie stars, stellar remnants that defy the natural order of the universe. These bizarre objects, often referred to as zombie stars, are the eerie survivors of supernova explosions, events so powerful they were thought to completely obliterate their parent stars. But instead of fading into cosmic dust, these stars somehow come back to life, defying our understanding of how stars live and die. Zombie stars challenge everything we thought we knew about stellar life cycles. Normally, when a massive star exhausts its fuel, it collapses under its own gravity and explodes in a supernova, leaving behind either a neutron star or a black hole. But zombie stars are different. They manage to survive the explosion, reigniting and continuing to burn, albeit in a strange and unpredictable way. This phenomenon has left scientists scratching their heads as it contradicts the standard models of stellar evolution. One of the most famous examples of a zombie star is the so-called Type 1Ax supernova. These supernovae occur when a white dwarf, a dense, Earth-sized remnant of a star, steals material from a companion star until it reaches a critical mass and explodes. But in some cases, the explosion doesn't completely destroy the white dwarf. Instead, it leaves behind a partially intact core that continues to burn, creating a zombie star. These stars are not only rare but also incredibly unstable, emitting bursts of energy that can outshine entire galaxies for brief moments. The existence of zombie stars raises unsettling questions about the nature of stellar death. If stars can survive supernova, what else might be possible in the cosmos? Could there be other forms of stellar remnants that we haven't yet discovered? And what does this mean for our understanding of the life cycles of stars? These questions remind us that the universe is far stranger and more unpredictable than we often assume. As we continue our journey through the most terrifying phenomena in space, zombie stars stand as a haunting reminder of the mysteries that still lie beyond our grasp. They challenge our understanding of the cosmos and force us to reconsider what we think we know about the life and death of stars. And with that, we move forward to another cosmic mystery, the Oort Cloud, a distant and enigmatic region of our solar system that holds its own terrifying secrets. Now turning to the outer reaches of our solar system, we encounter the Oort Cloud, a vast, mysterious shell of icy objects that encircles our cosmic neighborhood. This distant region, named after the Dutch astronomer Jan Oort, is believed to be the birthplace of long-period comets, those icy wanderers that occasionally streak across our skies. But while the Oort Cloud may seem like a quiet, frozen frontier, it holds the potential for sudden and terrifying disruptions. The Oort Cloud is thought to extend from about 2,000 to as far as 100,000 astronomical units from the Sun. To put that into perspective, 1 astronomical unit is the average distance between Earth and the Sun, so the Oort Cloud is unimaginably far away. This immense distance makes it nearly impossible to observe directly, leaving much of its nature shrouded in mystery. What we do know is that it's composed of trillions of icy bodies, remnants from the formation of the solar system over 4.5 billion years ago. What makes the Oort Cloud truly unsettling is its role as a cosmic reservoir of comets. Occasionally, gravitational disturbances, perhaps from a passing star or the tug of the Milky Way's gravity, can dislodge one of these icy objects, sending it hurtling toward the inner solar system. When this happens, the comet can become visible from Earth, creating a spectacular but potentially dangerous display. While most comets from the Oort Cloud burn up harmlessly or pass by without incident, there's always the possibility that one could collide with Earth with catastrophic consequences. The unpredictability of the Oort Cloud is what makes it so terrifying. Unlike asteroids, which often follow predictable orbits, comets from the Oort Cloud can appear seemingly out of nowhere, giving us little to no warning. A large comet impact could unleash devastation on a global scale, altering climates, triggering mass extinctions, and reshaping the course of life on Earth. It's a chilling reminder that even in the farthest reaches of our solar system, danger can lurk, waiting to strike without warning. As we ponder the mysteries of the Oort Cloud, we're reminded of how little we truly understand about the outer solar system. This distant, icy shell is a testament to the vastness and unpredictability of the cosmos, and it serves as a sobering reminder that our planet is not immune to the forces that govern the universe. With that in mind, we move forward to explore another cosmic phenomenon, hypervelocity stars, which race through space at unimaginable speeds, leaving destruction in their wake. Now turning to the realm of hypervelocity stars, we encounter one of the most extreme phenomena in the universe: stars that race through space at speeds so fast they can escape the gravitational pull of their own galaxies. These cosmic speedsters, traveling at millions of miles per hour, are not just fascinating, they're also a reminder of the sheer power and chaos that exist in the cosmos. Hypervelocity stars are born from violent events, often involving supermassive black holes. When a binary star system, a pair of stars orbiting each other, wanders too close to a black hole, one star can be captured by the black hole's immense gravity, while the other is flung outward at incredible speeds. This process, known as the slingshot effect, propels the ejected star to velocities so high that it can break free from its galaxy entirely, becoming a lone wanderer in the vastness of intergalactic space. But what makes hypervelocity stars truly terrifying is their potential for destruction. Traveling at such extreme speeds, these stars can collide with other celestial bodies or disrupt planetary systems they encounter. Imagine a star barreling through a solar system at millions of miles per hour. Its gravitational pull could fling planets out of their orbits, destabilize entire star systems, or even trigger catastrophic collisions. While the chances of a hypervelocity star directly impacting Earth are astronomically low, the sheer scale of their potential destruction is enough to send shivers down your spine. What's even more unsettling is that hypervelocity stars are nearly impossible to predict or track. Their trajectories are influenced by the chaotic forces that ejected them, making it difficult to determine where they might end up. This unpredictability adds to their mystique and danger, as they could appear in a region of space without warning, leaving chaos in their wake. As we reflect on the incredible speeds and destructive potential of hypervelocity stars, we're reminded once again of the universe's capacity for both beauty and terror. These stars are a testament to the immense forces at play in the cosmos, forces that can fling entire stars across galaxies and reshape the fabric of space itself. With this in mind, we move forward to explore another cosmic mystery: the hidden dangers lurking within the Kuiper Belt, a region of icy bodies that could hold unexpected threats for our solar system. Now turning to the Kuiper Belt, we venture into a distant and mysterious region of our solar system, a place where icy bodies and ancient remnants of the solar system's formation lie in wait. This vast expanse, stretching far beyond the orbit of Neptune, is home to countless objects, from small icy rocks to dwarf planets like Pluto. But don't let its serene, frozen appearance fool you. The Kuiper Belt holds hidden dangers that could pose a threat to Earth. The Kuiper Belt is a treasure trove of cosmic debris, a relic from the early days of our solar system. While many of its objects remain in stable orbits, others are influenced by the gravitational tugs of Neptune or other large bodies, sending them on unpredictable paths. Some of these objects could be nudged out of their orbits and sent hurtling inward toward the inner solar system, and potentially toward us. One of the most unsettling aspects of the Kuiper Belt is the possibility of undiscovered objects lurking within its depths. Despite our advances in astronomy, much of this region remains uncharted. There could be massive icy bodies or even dwarf planets that we haven't yet detected. And if one of these were to be dislodged from its orbit, it could become a comet or an asteroid on a collision course with Earth. The impact of such an object, depending on its size, could be catastrophic, rivaling the event that wiped out the dinosaurs millions of years ago. What makes this scenario even more chilling is the unpredictability of these objects. Unlike asteroids in the asteroid belt, which are closer and easier to monitor, Kuiper Belt objects are so distant and faint that they often escape detection until they're already on their way. By the time we spot one, it might be too late to take action. This uncertainty underscores the importance of continued exploration and monitoring of this distant region, as the next threat could be hiding in the shadows, waiting to emerge. As we consider the hidden dangers of the Kuiper belt, we're reminded of the delicate balance that keeps our solar system stable and how easily that balance could be disrupted. The icy bodies of the Kuiper belt are a reminder that even in the farthest reaches of our cosmic neighborhood, danger can lurk in the most unexpected places. With this in mind, we move forward to explore another cosmic phenomenon, the eventual death of our Sun, a process that will reshape the solar system in ways we can scarcely imagine. Now turning to the inevitable fate of our Sun, we confront a cosmic event that will reshape the solar system as we know it. The Sun, the life-giving star at the center of our solar system, has a finite lifespan, and its eventual death is a process both awe-inspiring and terrifying. In about 5 billion years, the Sun will exhaust its hydrogen fuel and begin to transform into a red giant, expanding to hundreds of times its current size. This expansion will have catastrophic consequences for Earth and the inner planets. As the Sun swells into a red giant, its outer layers will engulf Mercury and Venus, and Earth will face a grim fate. While our planet may not be completely consumed, the intense heat and radiation from the expanding Sun will scorch its surface, rendering it uninhabitable. Oceans will evaporate, the atmosphere will be stripped away, and any remaining traces of life will be obliterated. The once thriving blue planet will become a barren, lifeless rock, swallowed by the dying star that once nurtured it. The timeline of this event is both comforting and chilling. 5 billion years may seem like an unimaginably distant future, but it serves as a stark reminder of the impermanence of our cosmic home. Even more unsettling is the fact that long before the Sun reaches its red giant phase, its gradual increase in brightness will make Earth uninhabitable in about 1 billion years. This means that on a cosmic scale, humanity's time on Earth is fleeting, and the window for finding a new home among the stars is closing faster than we might think. The death of the Sun also raises profound questions about the future of life in the universe. As stars like ours age and die, they leave behind white dwarfs, dense remnants that slowly cool over trillions of years. But before that, the red giant phase will scatter the Sun's outer layers into space, creating a planetary nebula that will enrich the cosmos with the elements necessary for new stars and planets to form. In a way, the Sun's death will contribute to the birth of future worlds, a bittersweet reminder of the cyclical nature of the universe. As we contemplate the Sun's eventual demise, we're reminded of the fragility of our existence and the importance of cherishing the time we have. The death of our star is a humbling reminder that even the most stable and familiar aspects of the cosmos are subject to change. With this in mind, we move forward to explore another cosmic event that will reshape the universe: the collision between the Milky Way and the Andromeda Galaxy, a cataclysmic encounter that will redefine our place in the cosmos. Now turning to the inevitable collision between the Milky Way and the Andromeda Galaxy, we encounter a cosmic event that will redefine the structure of our universe. The Milky Way, our home galaxy, and Andromeda, our nearest galactic neighbor, are hurtling toward each other at a staggering speed of about 110 kilometers per second. In approximately 4.5 billion years, these two massive galaxies will collide, setting off a chain of events that will transform the cosmos as we know it. The collision itself will be a slow, chaotic process spanning hundreds of millions of years. As the galaxies merge, their immense gravitational forces will pull stars, gas, and dust into a swirling dance of destruction and creation. While the distances between stars are so vast that direct collisions are unlikely, the gravitational interactions will fling stars out of their orbits, creating a chaotic and unpredictable environment. Entire star systems could be ejected into intergalactic space, while others might be drawn into the heart of the newly forming galaxy. For our solar system, the consequences of this collision are uncertain but potentially dramatic. There's a chance that the Sun and its planets could be flung into a new orbit far from the galactic center, or even ejected entirely from the galaxy. However, the more likely scenario is that our solar system will remain relatively unscathed, orbiting within the newly merged galaxy. This new galaxy, often referred to as Milkomda or Milkdromda, will be a massive elliptical galaxy, vastly different from the spiral structure of the Milky Way we know today. The collision will also trigger a burst of star formation as clouds of gas and dust collide and compress, igniting the birth of countless new stars. Over time, this frenzy of activity will settle, and the new galaxy will stabilize, becoming a quieter, more uniform structure. While the process will be violent and chaotic, it will also be a creative force, shaping the future of the cosmos in ways we can only begin to imagine. As we contemplate this distant future, we're reminded of the dynamic and ever-changing nature of the universe. The collision between the Milky Way and Andromeda is a testament to the forces that shape galaxies and the interconnectedness of all cosmic structures. With this in mind, we move forward to explore another unsettling phenomenon, the vacuum decay theory, a hypothetical scenario that could spell the end of the universe as we know it. Now turning to the vacuum decay theory, we delve into one of the most unsettling hypothetical scenarios in physics, a phenomenon that could spell the end of the universe itself. This theory suggests that our universe exists in a false vacuum, a state that appears stable but is actually a precarious balance. If a tiny region of space were to transition into a true vacuum, it could create a bubble that expands at the speed of light, rewriting the fundamental laws of physics as it spreads. Everything within its path, galaxies, stars, planets, and even atoms, would be obliterated in an instant. The scientific basis for this theory lies in quantum field theory, which describes how particles and forces interact. According to this framework, the vacuum of space isn't empty but filled with energy fields. If one of these fields were to drop to a lower energy state, it could trigger a catastrophic chain reaction. The bubble of true vacuum would act like a cosmic reset button, erasing the universe as we know it and replacing it with something entirely different. While this scenario is purely theoretical, the implications are profound and deeply unsettling. What makes the vacuum decay theory so terrifying is its inevitability if it were to occur. Once the process begins, there's no way to stop it. The bubble would expand faster than the speed of light, leaving no time for escape or warning. Entire civilizations, planets, and galaxies would vanish without a trace, their existence erased in the blink of an eye. The sheer scale of destruction is almost incomprehensible, making it one of the most existential threats imaginable. Despite its terrifying nature, the vacuum decay theory also inspires a sense of awe. It reminds us of the delicate balance that governs the universe and the fragility of the reality we take for granted. While the likelihood of such an event is incredibly low, the mere possibility challenges our understanding of existence and forces us to confront the ultimate impermanence of everything we know. As we grapple with the implications of this theory, we're reminded once again of the mysteries that lie at the heart of the cosmos. With this in mind, we move forward to explore another chilling concept, the heat death of the universe, a scenario that paints a bleak picture of the universe's ultimate fate. Now turning to the heat death of the universe, we explore a chilling scenario that paints a grim picture of the cosmos' ultimate fate. This concept, rooted in the laws of thermodynamics, suggests that the universe is on an irreversible path toward maximum entropy, a state where all energy is evenly distributed and no usable energy remains. In simpler terms, it's the universe's way of running out of steam, where stars burn out, galaxies fade, and all activity grinds to a halt. The heat death of the universe is a slow, inevitable process. Over trillions of years, stars will exhaust their fuel, black holes will evaporate, and even the most stable particles will decay. Eventually, the universe will reach a state of complete equilibrium where no heat or energy gradients exist. Without these gradients, no work can be done and no life or motion can be sustained. the cosmos will become a cold, dark, and lifeless expanse devoid of any meaningful change. What makes this scenario so unsettling is its inevitability. Unlike other cosmic threats, the heat death of the universe isn't a sudden event but a gradual decline over an unimaginable timescale. It's a reminder that even the vast, dynamic universe we see today is finite, bound by the same physical laws that govern everything within it. The idea of a universe frozen in time where nothing new can ever happen is both humbling and deeply sobering. Yet, even in this bleak vision, there's a strange kind of beauty. The heat death of the universe forces us to confront the impermanence of all things, from the smallest atom to the largest galaxy. It challenges us to find meaning in the fleeting moments of existence and to appreciate the incredible complexity and energy that define our universe today. While the end may be cold and dark, the journey there is filled with wonder and awe. As we reflect on the heat death of the universe, we're reminded once again of the delicate balance that sustains the cosmos. With this in mind, we move forward to explore another terrifying concept, the Big Rip, a theory that suggests the universe could be torn apart by the relentless expansion of dark energy. Now turning to the Big Rip, we delve into a theory that paints an even more catastrophic end for the universe than the heat death. The Big Rip suggests that dark energy, the mysterious force driving the accelerated expansion of the cosmos, could grow so powerful over time that it tears apart everything in existence: galaxies, stars, planets, and even atoms themselves. Unlike the slow, cold demise of heat death, the Big Rip is a violent and dramatic finale where the fabric of reality is shredded by the relentless pull of dark energy. At the heart of this theory is the idea that dark energy's influence isn't constant but increases as the universe expands. Over billions of years, this growing force would overcome gravity, the force that holds galaxies together, and eventually overpower even the strongest atomic bonds. First, galaxies would be ripped apart, their stars flung into the void. Then, solar systems would disintegrate, planets torn from their orbits. Finally, as dark energies grip titans, even atoms and subatomic particles would be pulled apart, leaving nothing but a chaotic sea of fundamental particles. What makes the Big Rip so terrifying is its inevitability, much like the heat death of the universe, but with a far more destructive outcome. If dark energy behaves as this theory predicts, there's no escape, no corner of the universe would remain untouched. The very laws of physics that hold reality together would be undone, leaving behind a universe that's not just cold and lifeless, but utterly fragmented. The Big Rip also raises profound questions about the nature of dark energy itself. What is this force, and why does it seem to grow stronger over time? Could it one day be harnessed or controlled, or is it an unstoppable force of nature? These questions remain unanswered, adding to the mystery and dread surrounding this potential cosmic endgame. As we contemplate the Big Rip, we're reminded of the fragility of the universe and the delicate balance that allows it to exist. It's a stark contrast to the heat death, yet both theories underscore the same truth that the cosmos, for all its grandeur, is not eternal. With this in mind, we move forward to explore another unsettling mystery, the strange and enigmatic behavior of Tabby's star, a celestial object that has baffled scientists and sparked theories of alien megastructures. Now turning to the mystery of Tabby's star, we encounter one of the most perplexing and unsettling phenomena in the cosmos. Officially known as KIC 8462852, this star, located approximately 1,400 light-years from Earth, has baffled astronomers with its bizarre and unpredictable dimming patterns. Unlike most stars which dim in regular, predictable cycles, Tabby's star experiences sudden and dramatic drops in brightness, sometimes by as much as 22% before returning to normal. These irregular fluctuations have sparked intense speculation and even led to theories of alien megastructures. The most famous explanation for these strange dimming patterns is the idea of a Dyson sphere, a hypothetical structure built by an advanced extraterrestrial civilization to harness the energy of a star. Proposed by physicist Freeman Dyson in the 1960s, a Dyson sphere would consist of a massive array of solar panels or other energy-capturing devices surrounding a star, effectively blocking some of its light from reaching observers on Earth. While this idea remains speculative, the unusual behavior of Tabby's star has made it a prime candidate for such a possibility. However, scientists have also proposed more natural explanations for the star's dimming. Some suggest that the irregular patterns could be caused by a massive cloud of dust or debris orbiting the star, possibly from a collision between planets or the remnants of a disintegrating comet. Others have theorized that the star itself might be undergoing internal changes, such as magnetic activity or pulsations, that cause its brightness to fluctuate unpredictably. Despite these possibilities, none of the natural explanations fully account for the star's extreme and irregular dimming, leaving the mystery unsolved. What makes Tabby's star so unsettling is the tantalizing possibility that we might be witnessing evidence of an advanced extraterrestrial civilization. If the dimming patterns are indeed caused by a Dyson sphere or similar structure, it would imply the existence of a civilization far more technologically advanced than our own, one capable of engineering on a cosmic scale. This raises profound questions about the nature of intelligence in the universe and our place within it. Are we alone, or are we merely one of many civilizations scattered across the cosmos? As we ponder the mystery of Tabby's star, we're reminded of the vastness of the universe and the countless secrets it holds. Whether the star's dimming is the result of alien megastructures or a natural phenomenon yet to be understood, it serves as a humbling reminder of how much we still have to learn about the cosmos. With this in mind, we move forward to explore another cosmic enigma, the deadly beams of radiation emitted by pulsars, which could pose a catastrophic threat to any nearby planetary systems. Now turning to the chilling phenomenon of pulsars, we encounter one of the most destructive forces in the universe. Pulsars are highly magnetized neutron stars, the remnants of massive stars that have exploded in supernova. These incredibly dense objects spin at astonishing speeds, some completing hundreds of rotations every second. As they spin, they emit intense beams of radiation from their magnetic poles, creating a lighthouse-like effect that can be detected across vast distances. What makes pulsars so terrifying is the sheer power of their radiation beams. These beams are composed of high-energy particles, including X-rays and gamma rays, which are capable of stripping away atmospheres, frying electronics, and sterilizing any life forms in their path. If a pulsar were to form relatively close to Earth within a few dozen light years, its beams could pose an existential threat to our planet. Even a brief exposure to such radiation could devastate ecosystems, disrupt global communications, and render Earth uninhabitable. The danger lies not just in the pulsar's beams, but also in their unpredictability. Pulsars can suddenly change their rotation speed or the direction of their beams, making it nearly impossible to predict when or where their deadly radiation might strike. This unpredictability, combined with their immense power, makes pulsars one of the most feared objects in the cosmos. While the likelihood of a pulsar forming near Earth is low, the consequences would be catastrophic if it happened. The beams could reach Earth in a matter of seconds, leaving no time for preparation or evacuation. This scenario serves as a stark reminder of the universe's capacity for destruction and the fragility of life in the face of such cosmic forces. As we reflect on the terrifying potential of pulsars, we're reminded once again of the universe's dual nature, both awe-inspiring and perilous. With this in mind, we move forward to explore another cosmic phenomenon that challenges our understanding of the universe, the immense power of quasars, the brightest and most energetic objects in existence. Now turning to the awe-inspiring yet terrifying phenomenon of quasars, we encounter some of the most luminous and energetic objects in the cosmos. Quasars, short for quasi-stellar radio sources, are the blazing cores of distant galaxies powered by supermassive black holes at their centers. These black holes, millions or even billions of times more massive than our Sun, devour surrounding matter at an astonishing rate. As this matter spirals into the black hole, it heats up to incredible temperatures, releasing vast amounts of energy in the form of light, radio waves, and X-rays. The result is a quasar, a beacon of light so intense that it can outshine entire galaxies. What makes quasars truly terrifying is their sheer destructive power. The energy they emit is so immense that it can strip away the atmospheres of nearby planets, ionize gas clouds across vast distances, and disrupt the formation of stars in their host galaxies. A quasar's radiation can travel billions of light years, making it visible from the farthest reaches of the universe. Yet, this same energy that makes quasars so brilliant also makes them deadly. If a quasar were to form in our galactic neighborhood, its radiation could sterilize planets, obliterate life, and render entire solar systems uninhabitable. Adding to their fearsome nature is the fact that quasars are not static. They can flare up suddenly, increasing their brightness by orders of magnitude in a matter of days or even hours. These outbursts are unpredictable and can release as much energy in a single flare as our Sun will emit over its entire lifetime. Such an event, if it occurred nearby, would be catastrophic for any life forms caught in its path. Despite their destructive potential, quasars also offer a glimpse into the early universe. Because they are so bright, they serve as cosmic lighthouses, illuminating the distant past and helping astronomers study the conditions of the universe billions of years ago. Yet, this duality of being both a tool for discovery and a source of unimaginable destruction only adds to their mystique and terror. As we contemplate the immense power of quasars, we're reminded once again of the universe's capacity for both creation and annihilation. With this in mind, we move forward to explore another cosmic phenomenon that challenges our understanding of the universe: the catastrophic consequences of neutron star collisions, where unimaginable forces collide to reshape the fabric of space and time. Now turning to the cataclysmic events of neutron star collisions, we enter a realm where the universe's most extreme forces collide. Neutron stars are the dense remnants of massive stars that have exploded in supernova. These stellar corpses are so compact that a single teaspoon of their material would weigh billions of tons on Earth. When two neutron stars spiral toward each other, locked in a deadly dance by gravity, their collision unleashes energy on a scale that defies imagination. The moment of impact is nothing short of apocalyptic. The collision generates gravitational waves, ripples in the fabric of space-time that can be detected across the universe. But that's just the beginning. The merger also produces a burst of gamma rays, the most energetic form of light, capable of outshining entire galaxies for a brief moment. This gamma ray burst, if directed toward Earth, could strip away our planet's ozone layer, exposing all life to deadly ultraviolet radiation from the Sun. The aftermath would be devastating, potentially triggering mass extinctions and altering the course of life on Earth. But the destruction doesn't stop there. The collision often results in the formation of a black hole, a region of space-time where gravity is so intense that not even light can escape. Surrounding matter is drawn into this newly formed black hole, creating a swirling disk of superheated gas that emits intense radiation. This process, known as a kilonova, also produces heavy elements like gold, platinum, and uranium, scattering them across the cosmos. In a way, these violent events are the cosmic forges that create the building blocks of planets and life itself. What makes neutron star collisions particularly unsettling is their unpredictability. While such events are rare, occurring roughly once every 100,000 years in a galaxy like the Milky Way, their potential impact is immense. If a collision were to happen within a few thousand light years of Earth, the consequences could be catastrophic. the gamma ray burst alone could disrupt satellite communications, damage power grids, and pose a significant threat to astronauts in space. Yet, despite their destructive potential, neutron star collisions also offer a unique window into the workings of the universe. By studying these events, scientists can test theories of gravity, explore the origins of heavy elements, and gain insights into the behavior of matter under extreme conditions. This duality of being both a source of destruction and a tool for discovery mirrors the paradoxes we've encountered throughout our journey into the cosmos. As we reflect on the immense power of neutron star collisions, we're reminded once again of the delicate balance that governs our universe. With this in mind, we move forward to explore another mysterious phenomenon, the enigmatic dark flow, where clusters of galaxies appear to move in unison, defying our understanding of cosmic motion. Now turning to the mysterious phenomenon of dark flow, we encounter yet another cosmic puzzle that challenges our understanding of the universe. Dark flow refers to the peculiar motion of galaxy clusters, which appear to be moving in a specific direction at incredible speeds far faster than can be explained by the known forces of gravity and the expansion of the universe. This strange movement was first detected by studying the cosmic microwave background, the faint afterglow of the Big Bang, which revealed subtle distortions caused by the motion of these clusters. What makes dark flow so unsettling is that it defies our current models of cosmology. According to the standard understanding, the universe is expanding uniformly, with galaxies and clusters moving apart in all directions. Yet, dark flow suggests that something massive beyond the observable universe is exerting a gravitational pull on these clusters, dragging them toward an unseen destination. This raises the possibility of structures or forces existing outside the boundaries of what we can see, hinting at a universe far larger and more complex than we ever imagined. One leading theory proposes that dark flow could be caused by the gravitational influence of other universes in a multiverse. If our universe is just one of many, it's possible that neighboring universes are exerting a pull on our own, creating this mysterious motion. Another theory suggests that dark flow might be the result of massive, undiscovered structures within our universe, such as superclusters of galaxies or even exotic forms of matter that we have yet to detect. The implications of dark flow are profound. If confirmed, it could revolutionize our understanding of the cosmos, revealing hidden dimensions, parallel universes, or entirely new physics. At the same time, it serves as a humbling reminder of how much we still don't know about the universe. Despite our advancements, the cosmos continues to surprise us with its mysteries, pushing the boundaries of science and imagination. As we ponder the enigma of dark flow, we're reminded that the universe is a place of endless wonder and uncertainty. With this in mind, we move forward to explore another cosmic mystery, the cannibalistic galaxies, where the universe's largest structures consume their neighbors in a violent dance of destruction and creation. Now turning to the cannibalistic galaxies, we delve into one of the most violent and awe-inspiring processes in the cosmos. Galaxies, often thought of as serene islands of stars, are not always peaceful. In fact, some galaxies engage in a brutal act of cosmic consumption, devouring their smaller neighbors to grow larger and more powerful. This process, known as galactic cannibalism, is a stark reminder of the universe's relentless and often destructive nature. The Milky Way itself is no stranger to this phenomenon. Over billions of years, our galaxy has absorbed smaller satellite galaxies, incorporating their stars, gas, and dark matter into its own structure. One of the most famous examples is the Sagittarius dwarf galaxy, which is currently being torn apart by the Milky Way's gravitational pull. As it spirals closer, its stars are being stripped away, eventually becoming part of our galaxy's halo. This ongoing process not only shapes the Milky Way structure, but also fuels the formation of new stars from the captured gas. But galactic cannibalism isn't just a one-way street. Larger galaxies, like the Andromeda Galaxy, are also on the prowl. In fact, Andromeda is expected to collide with the Milky Way in about 4 billion years, leading to a spectacular merger. When this happens, the two galaxies will engage in a violent dance, tearing each other apart before eventually merging into a single, even larger galaxy. While this event won't pose a direct threat to Earth, it will dramatically alter the night sky, creating a chaotic swirl of stars and gas. The implications of galactic cannibalism extend beyond just the merging of stars and gas. It also plays a crucial role in the evolution of galaxies, influencing their shapes, sizes, and even the supermassive black holes at their centers. As galaxies consume one another, their central black holes can merge, releasing enormous amounts of energy in the form of gravitational waves. These cosmic ripples, first detected in 2015, provide a new way for astronomers to study the universe's most violent events. As we reflect on the cannibalistic nature of galaxies, we're reminded of the universe's dynamic and ever-changing character. What seems like a serene expanse of stars is in reality a battlefield of cosmic proportions where galaxies grow, evolve, and sometimes destroy one another. With this in mind, we move forward to explore another cosmic mystery, the wandering planets, rogue worlds that drift through space without a star to call home. Now turning to the wandering planets, we uncover another eerie phenomenon in the vastness of space. These rogue planets, often called orphan worlds, drift through the cosmos without being tethered to any star. Unlike the planets in our solar system, which orbit the sun in predictable paths, these wandering worlds are nomads, traveling alone through the darkness of interstellar space. The existence of rogue planets challenges our understanding of planetary formation. Scientists believe these planets may have been ejected from their original solar systems due to gravitational interactions with larger bodies, such as gas giants or passing stars. Some may have even formed independently in the cold, dense regions of space, never having belonged to a star system at all. Their solitary journeys make them difficult to detect, as they emit no light of their own and are often too far from any star to reflect light. But what makes these wandering planets truly terrifying is their potential for chaos. Without a star to anchor them, rogue planets can travel at incredible speeds, crossing paths with other solar systems. If one were to enter a star system, its gravitational pull could disrupt the delicate balance of orbiting planets, potentially flinging them out of their stable orbits or even causing catastrophic collisions. Imagine a rogue planet the size of Jupiter hurtling toward Earth. Its sheer mass and speed could spell doom for our planet and the entire solar system. Even more unsettling is the possibility that rogue planets could harbor life. Some scientists speculate that these wandering worlds might have subsurface oceans or thick atmospheres that trap heat, creating environments where life could potentially survive. If true, this raises the chilling prospect of entire ecosystems adrift in the void, cut off from the warmth and energy of a star. As we ponder the mysteries of these wandering planets, we're reminded of the unpredictability of the cosmos. These rogue worlds, drifting silently through the darkness, serve as a stark reminder of how much we still have to learn about the universe. With this in mind, we move forward to explore another cosmic enigma, the cosmic microwave background, the faint afterglow of the Big Bang that holds clues to the universe's origins and ultimate fate. Now turning to the cosmic microwave background, we delve into one of the most profound discoveries in modern astronomy. This faint glow, often referred to as the afterglow of the Big Bang, is the oldest light in the universe, dating back to just 380,000 years after the universe began. It is a snapshot of the infant cosmos, a time when the universe was hot, dense, and filled with a searing plasma of particles and energy. As the universe expanded and cooled, this plasma recombined into neutral atoms, allowing light to travel freely for the first time. This light, stretched and cooled over billions of years, is what we now detect as the cosmic microwave background. The cosmic microwave background is not just a relic of the past, it is a treasure trove of information about the universe's origins. Tiny fluctuations in its temperature reveal the seeds of cosmic structure, the slight variations in density that would eventually grow into galaxies, stars, and planets. Without these fluctuations, the universe would be a featureless void, devoid of the complexity we see today. Yet, while this discovery has deepened our understanding of the universe's beginnings, it also raises unsettling questions about its ultimate fate. One of the most chilling implications of the cosmic microwave background is its connection to the concept of entropy, the measure of disorder in the universe. The universe began in a state of extremely low entropy, a highly ordered and energetic state. Over time, as the universe expanded and evolved, entropy has been steadily increasing. The cosmic microwave background shows us that the universe is on an irreversible path toward maximum entropy, a state known as heat death. In this distant future, all stars will burn out, all matter will decay, and the universe will become a cold, dark, and lifeless expanse. This bleak prospect forces us to confront the impermanence of everything we know. The cosmic microwave background, while a testament to the universe's birth, also serves as a reminder of its inevitable end. It challenges us to grapple with the idea that even the most enduring structures in the cosmos are temporary, destined to fade into the void. As we reflect on the cosmic microwave background and its implications, we are reminded of the delicate balance that governs the universe. From the faint glow of the Big Bang to the eventual heat death of all things, the cosmos is a place of both creation and destruction, of beginnings and endings. With this in mind, we move forward to explore another cosmic mystery, the black hole information paradox, a puzzle that challenges our very understanding of reality. Now turning to the black hole information paradox, we enter one of the most perplexing mysteries in modern physics. At its core, this paradox challenges our fundamental understanding of how information behaves in the universe. According to the laws of quantum mechanics, information about the state of a system can never be truly lost. It might change form, but it is always preserved. However, black holes seem to defy this principle. When matter falls into a black hole, it is crushed into an infinitely dense point called a singularity. According to classical physics, all information about that matter, its composition, structure, and history, is seemingly lost forever, erased from the universe. This contradiction between quantum mechanics and general relativity has left scientists grappling with profound questions. If information truly disappears in a black hole, it would mean that our understanding of the universe is incomplete or even fundamentally flawed. This paradox has sparked decades of debate and led to groundbreaking theories, such as Stephen Hawking's proposal that black holes emit radiation, now known as Hawking radiation. This radiation suggests that black holes slowly lose mass and eventually evaporate, but it still doesn't fully resolve the question of what happens to the information trapped inside. The implications of the black hole information paradox extend far beyond black holes themselves. It forces us to reconsider the nature of reality, the fabric of space-time, and the very laws that govern the universe. Some theories suggest that information might be encoded on the event horizon of a black hole, the boundary beyond which nothing can escape. Others propose that information could be stored in alternate universes, or even that black holes might be gateways to entirely different dimensions. These ideas, while speculative, highlight the profound mysteries that black holes present. What makes this paradox so unsettling is its potential to upend our understanding of physics. If information can be lost, it would mean that the universe operates in ways we cannot yet comprehend. It challenges the idea that the universe is predictable and governed by immutable laws, introducing an element of uncertainty that shakes the foundations of science. As we continue to explore this paradox, we are reminded that the universe is far stranger and more complex than we can imagine. With the black hole information paradox still unresolved, we are left to ponder the nature of reality itself. What does it mean for information to be lost? Could there be hidden layers of the universe that we have yet to uncover? These questions not only deepen our curiosity, but also remind us of the vast unknowns that lie at the heart of the cosmos. As we move forward, we turn our attention to another mind-bending concept, the multiverse theory, which suggests the existence of infinite parallel universes, each with its own unique set of possibilities. Now turning to the multiverse theory, we dive into one of the most mind-bending concepts in modern cosmology. This theory suggests that our universe might not be the only one. Instead, there could be an infinite number of parallel universes, each with its own unique set of physical laws, constants, and even versions of reality. Imagine a universe where gravity is stronger, or one where life evolved in ways we can't even begin to comprehend. The possibilities are as vast as they are unsettling. The multiverse theory arises from several areas of physics, including quantum mechanics and string theory. In quantum mechanics, every possible outcome of a situation might exist in its own separate universe. For example, if you flip a coin, there could be one universe where it lands on heads and another where it lands on tails. String theory, on the other hand, suggests that our universe is just one of many brains floating in a higher dimensional space, each representing a different universe. These ideas, while speculative, offer a tantalizing glimpse into the complexity of existence. What makes the multiverse theory so fascinating and terrifying is the existential questions it raises. If there are infinite universes, does that mean there are infinite versions of you, each living a slightly different life? Could there be a universe where every decision you made turned out differently? The idea challenges our understanding of identity, free will, and the very nature of reality. It also raises the possibility that somewhere out there, a universe exists where Earth never formed or where humanity never evolved. The multiverse theory also has profound implications for the search for extraterrestrial life. If there are infinite universes, the chances of life existing elsewhere skyrocket. But it also means that life could take forms so alien that we might not even recognize it. This theory forces us to confront the limits of our imagination and the vastness of the unknown. As we ponder the multiverse, we are reminded once again that the universe or universes are far stranger and more complex than we can ever fully grasp. The multiverse theory doesn't just expand our understanding of reality, it shatters it, leaving us with more questions than answers. And as we conclude our journey through the 25 most terrifying things in space, we are left with a sense of awe and humility, knowing that the mysteries of the cosmos are as infinite as the universes themselves. Now turning to the conclusion, we reflect on the 25 most terrifying things in space that we've explored together. From the mysterious pull of the Great Attractor to the mind-bending possibilities of the multiverse, each phenomenon reminds us just how vast, strange, and often unsettling the cosmos truly is. These cosmic mysteries challenge our understanding of reality, forcing us to confront the limits of our knowledge and the sheer scale of the unknown. Whether it's the destructive power of gamma-ray bursts, the eerie emptiness of the Boötes Void, or the existential dread of the Big Rip, the universe is filled with wonders that inspire both awe and fear. As we wrap up this journey, we invite you to share your thoughts. Which of these 25 terrifying phenomena sent the biggest shiver down your spine? Was it the wandering rogue planets, the cannibalistic galaxies, or the chilling possibility of vacuum decay? Let us know in the comments below. And if you've enjoyed this deep dive into the mysteries of space, don't forget to hit the like button, subscribe to the channel, and ring the notification bell so you never miss out on more mind-blowing explorations of the cosmos. The universe is vast and its secrets are endless, so stay curious, and we'll see you in the next video.